In episode 2, I created my Goaddon account and used it to create an app called Goexplore. The Goexplore add-on is now hosting the app using my own domain, goecommerce.app. Any e-commerce company can sign up there, and when they do, I'm using the GoFetch add-on to exchange data between their shops and the app. At the same time, I opened Christopher's Farm, a shop that sells fertilized eggs. I've already created a Goexplore account for Christopher's Farm, so I'm gonna spend this episode making the app useful. And it's not only going to be useful to my own shop, but to all e-commerce companies who are growing their own products. In fact, I intend to automate both inventory and order management of such a company to a degree where they no longer need laptops.
So let me first describe how I manage the inventory of Christopher's Farm today. My stock counts change every time I pick up new eggs. To update in my shop, I need to find the product in question, open the product page, scroll down, and register the new stock count. Then save my changes and repeat the process for other products.
The Goexplore solution to this inefficiency will be QR codes. Say that I've picked up 5 eggs. As you'll see in this episode, I'm going to implement that if I scan this code with my phone, Goexplore increases the stock count in my Shopify merchant account by 5. If I scan this code, it should be decreased by 2, and so on.
To begin implementing this, I now need to confirm the superuser that was created in my previous episode. A process that takes me from my inbox to the Goexplore website, where I'll choose a password and save it. While two-factor authentication is optional for regular users, it's required for superusers. So I'm going to scan this QR code with my Authenticator app and verify with the PIN displayed on my phone. Next up, we should talk about repositories on Goexplore. Think of a repository as a folder of text files on your laptop containing code that is translated into web pages on Goexplore-enabled websites. The shortcut I applied in episode 2 installed this repository that enables the pages we've browsed to see products and orders of a shop. The shortcut also installed this repository that embeds the GoFetch interface into the website, allowing merchants to register their online shops. Repositories can be deployed from version control websites such as GitHub, and they consist exclusively of HTML and JSON files, which means they should be well within the comfort zone of any web developer. Let's install a repository that contains the source code for my demo app. I've written it in my preferred text editor and pushed it to GitHub. It belongs to the organization Goaddon and is called Goexplore Demo. Let me install it and choose my branch. Let's review a few lines of code from within my text editor. If I want to create a new page on my website, I'll go to the templates folder. In there, I can find the pages folder and create an HTML file. The page that I've created here is named Variance Scan. When I deploy my repository in a moment, this HTML file will create a web page on a path that looks like this. The variance part of the path is equal to the first part of the file name, and the scan part of the path is equal to the last part of the file name. The ID in the middle is a URL parameter that can be given any value. That value will become accessible inside the template file as params ID. Let's take a moment to dig deeper into the template file name conventions. There's a template name for each of the usual CRUD operations that the HTTP protocol is optimized for. All template files that begins with variance will have this part of the URL in common, so let's copy that. GET requests to the URL we just copied would be routed to variance index. The typical job of such a template would be to display a list of variants. If we extend this path to include /new, the request would be targeting the template variance new. Put any other value in place of new and the request would instead target a variance show template. The provided value would then be accessible as params ID. Putting yet another slash after the ID would route the request to a template that matches the first and last part of the path, which is why this current file that ends with scan receives requests like this. A post request to the variance path would be routed to the variance create template, and any data from the request body would be accessible as params. Any put or patch request that includes an ID parameter is routed to the template named variance update. The request body of such requests would also be accessible as params. And finally, a delete request that includes an ID would go to a variance destroy template. Let's delete these comments and refocus on variance scan, a name that indicates our intention to scan a variant with a specific ID. So what is a variant? You can think of a variant as a variation of a product. A product with many variations will have many variants in your database, like small, medium, and large. And each variant would have its own stock count. Even if a product doesn't have variations, it would still have one variant that contains its stock count. Let me deploy my repository so I can visit the variance scan page. Deploying will create all of the pages, menu entries, images, and background jobs that are defined in the repository. But I can only see them when signed in to an account. As a super user, I can use the Goexplore app on behalf of any existing account. For the rest of this episode, I'll follow the account of Christopher's Farm. In my search for a variance scan page, I'm going to browse the products from this shop and select one. Since it does not have any variations, it only has a single variant. There's no link to the scanning page of this variant. I don't really need one, but I'll create it just to show how you can change a web page directly on the website as a super user. Since the path of this current page is variance, then a slash, then an ID, the template file that generates it must be named variance show. To find that template, we'll need to go to the pages menu entry and choose the page we just came from, called variance show. As you see from the link, this page belongs to one of the repositories I installed with a shortcut during episode 2. It's not recommended to manage your website directly from this interface, and since the page belongs to a repository, any change I apply here will be overwritten next time I redeploy. So in order to make permanent changes, I would need to fork the repository. Anyway, let's look at the page. It uses the template language Liquid to combine static HTML with dynamic tooling such as if statements, loops, objects, and operators. The first line uses this Liquid tag called dbFind to query the Goexplore database for a variant with whatever ID is specified as a parameter in the request URL. The query also needs a company ID, which should be equal to the ID of the signed-in user's account. If a user has been authenticated, this template has access to a user variable and an account variable that represents the account that the user belongs to. As you'll see in a moment, while the Goexplore variable is called account, the document class in your database is called company. The query has been named variance, and the actual query can be found in the queries section of this web page. The variance query finds any documents of the class variance that matches a company ID equal to the specified company ID and also matches an ID equal to the specified ID. As you'll see going forward, most queries to the database includes a company ID, even this one that knows exactly what ID it wants. Because now that any merchant can sign up and integrate their own shop, it's important only to give them access to their own data. The query returns a list of variants that we assign to a variable called Variance Query. We then assign the first result of the variance query to a variable called document. Skipping ahead to the end of the HTML file, a snippet called variant is included. A snippet is simply another HTML file. Let's navigate to the Snippets menu entry and find the snippet called Variant. In here we see a headline that uses Liquid to render a localized text. For the English version of the website, as is the case here, headline 1 would be translated into the word variant. More Liquid logic goes into the headline, but let's add our scanning link immediately after it in the form of an A tag to the variant's scan page. The Liquid tag called path4 will translate variant's scan into a real path that includes the ID of the specific variant that is represented by the document variable. I won't spend time localizing the link text. Instead, I'll save this masterpiece and navigate back to the product page. From there, I'll go to the variant page where a link has emerged. Let's follow it. As the URL indicates, we have now arrived at the page that is rendered by the variance scan template. It seems my request is missing a stock change parameter, like this. Let's revisit the file that is responsible for this page in the Goexplore demo repository. On line 1, we are indeed checking if the stock change parameter exists. If it doesn't, we throw an error. Similar to the variance show page that we just modified, the actual error message is localized, this one with the key called no stock change parameter. In my folder structure, localization files are located under Locales, Pages. The localization file is called variancescan.json, which connects it to the template file of the same name. Right now I have two languages, English and Danish, and both languages has a localized version of the message we saw on the website before. Anyway, if a stock change parameter does exist, I move on to check if the requested variant exists. It only does if the GoFetch add-on has transferred it from the shop to the database of Goexplore, and I can test that with a query named variance. I don't need to pull the variant from the database, I just want to make sure that it exists. So I'm using a Liquid filter called dbCount, which returns the number of matching documents rather than the documents themselves. I'll pass my query the ID of the variant, which is specified as a parameter in the URL of the page I just visited. And as company ID, I'll pass the ID of the account that the current signed-in user belongs to. The queries file is located under Queries, Pages, and the file is called variancescan.json, same name as the template file. The query, which is called variance, looks for all documents of the class variance. And the query can use the informations that I pass it. In other words, it can count the number of documents that has the specified ID and company ID. Exactly one document should match this query, and back in my template file, I'll complain if that's not the case by displaying a localized text called no variant. But if we have a match, we assign the stock change parameter from the request URL into a variable called stock change. Next up, we can request the shop to change the stock count. We do that with an API request, but the request does not go to the shop directly. Instead, it goes to the shop API that the GoFetch add-on makes available to Goexplore. By using the shop API, I don't have to care which e-commerce platform a particular shop is using. API requests are made with the Liquid filter called Webhook. And more specifically, I'm using a webhook that I have named Update Variant. I pass it a variant ID, which was a parameter in the requested URL, and a stock change, which comes from the stock change variable I just assigned from another parameter. The specifics of the API request is found under Webhooks, Pages, and the file is called variancescan.json, same name as the template file. The update variant webhook is just a standard patch request that in the URL includes the variant ID we passed to it. In the request body, we submit the stock change that originated from the parameters of the request to variance scan. When the shop API receives this request, it will check if our headers include an authorization key with the correct shop API token. We'll come back to that token in a moment, but if it checks out, GoFetch will request the shop, in this case Christopher's Farm, to change the stock count. This will not change anything in the database of GoCommerce. It only changes the stock count in the shop where this variant belongs. But since GoCommerce is integrated with the shop through GoFetch, GoFetch should subsequently pick up on this stock change and change it accordingly in the database of the app. Back in the template file, if the API request was unsuccessful, I'll display an error. Otherwise, I'll just let the user know that everything went fine. Let's check how it plays out. Seems we're getting an error, and this is because I haven't yet provided the GoCommerce app with the API token that is needed in order to communicate with the shop API of the GoFetch add-on. In order to provide this token, I need to revisit the GoCommerce account at Goaddon, where each add-on I've subscribed to has its own menu entry. One for Goexplore, the add-on that is hosting my website, and one for GoFetch, the add-on that provides me with shop integrations. By navigating to Shop API in the sub-menu, I can review the token and copy it. Next, I will navigate to Goexplore and Secrets. I'm going to paste in the Shop API token, and once it's saved, the repository will be able to access it through Project Secrets GoFetch API token. To make sure that I save it with the correct name, I will copy it from the repository and paste it in as the key of the secret. Now where the secret has been saved, let's check again if we can change the stock count. This time we get a successful response. And when we navigate back to products, find the product in question, and from there navigate to the variant page, we'll see that the change has already been communicated back to GoCommerce. The stock count has been increased from 10 to 11. Let's move on. Since I won't be using my laptop to visit the scanning page, I don't really need the link at the top of this page. Let's change the link into something I do need by navigating back to Superuser, Snippets, and find the variant snippet. Instead of the scan page, our link should go to a print page. Let's also change the link text to reflect this. I'm gonna save my changes, navigate back to products, find a product, continue to its variant, and then check out this new print page. Here I have prepared, as a page template in the GoCommerce demo repository, QR codes that merchants can print.
Let's give it a go by increasing my stock count by 7. Seems it worked. So using QR codes, a company can now manage their inventory without ever having to touch a computer. Let's move on to the next challenge, order management.
Let me describe how I manage orders on Christopher's Farm today. When orders arrive, I would need to sign in to my Shopify merchant account, check out my new orders, somehow find out which orders have sufficient inventory to be shipped. Then for each order, capture the payment, print shipping labels, and change the status of the order. Instead, I just want my printer to print a shipping label whenever there is sufficient inventory to process an open order. So let's implement it. Our implementation will rely on GoFetch to notify GoCommerce every time an order or product has been created or updated. Other approaches exist, but mine is to ask GoFetch for a webhook notification. The page template to receive it is called GoFetch Events Create, which translates into a post request that looks like this. To inform the GoFetch add-on that this is our chosen webhook path, let's copy it and tap back to the Goaddon account of GrowCommerce. From here, I can navigate to the Go Fetch menu entry, find webhooks in the sub-menu, and paste in the webhook URL. Anyone can use this URL to pretend to be Go Fetch. So back in my repository, on the first line, I need to authorize the request. I'll first check if the repository even has a copy of the valid authorization token. And I'll then compare if it's equal to the one provided in the request headers. The authorization token has been generated by Go Fetch. But Goexplore is a different add-on, so we need to copy the token from Go Fetch, navigate to Goexplore, find our way to Secrets, and paste in the token. Like last time, I will copy the name of the secret from the repository to make sure I get it right. So the request from Go Fetch will contain a few different informations. It contains an event parameter, and we're only interested if that event is either called fetched data or received data. By analyzing the parameters further, we can determine if any variants have been updated. If that's the case, it may be because a new order has been created, and the app should then check if the shop has sufficient stock to process that order. It's also possible that the merchant just scanned a QR code to increase the stock count of a variant. And in that case, the app should recheck if any existing orders are already waiting for it. In any case, the app needs to evaluate all open orders, which could take a few seconds. Since an HTTP request quickly times out, let's delegate this task to a background job. On this line, we'll use a liquid filter called createJob to start a job called printOrders. We can pass a company ID to the job because one of the parameters of the webhook request is the ID of a company. On our previous pages, like for instance Variance Scan, we had access to the account of the signed-in user, but the web page rendered by this template will not be visited by signed-in users. Rather, it will be requested by Go Fetch, and only because Go Fetch provides the ID of a company, we can limit the scope of the job to the specific company, like Christopher's Farm. The background job template is located in the Jobs folder. It uses the DB find filter to query the GrowCommerce database for orders belonging to the company ID that we passed to the job and can now access as a parameter. Just like a page template can access params of the HTTP requests, job templates can access the informations that we pass as params. The query is found under Queries, then Jobs, in a file with the same name as the template file, printorders.json. The query is limited to orders that belongs to the specified company ID, and we're only interested in orders in the state called open. I'm also only interested in a subset of order informations, most of them related to the shipping address. You're not required to specify which informations you would like from the database, but doing so will save resources. If no open orders exists, the job can finish, but otherwise we'll assign an orders variable based on the results of the orders query. Next up, we should find all order lines that belongs to any of the identified orders. Since an order line has a reference to the ID of the order it belongs to, we're creating a list of order IDs. We do that by iterating through each order and adding its ID to the order IDs list. We need the list for our next query, called order lines. This query uses the company ID as always and the order IDs. The specifics of the query looks like this. It finds documents of the class order lines, but only those that belongs to the specified company ID and also belongs to any of the identified orders. The returned order lines will have an order ID attribute that matches the ID of one of the orders. Aside from this, we're only interested in a subset of order line informations, one of them being the quantity that was ordered of the specific order line. And then we're interested in the variant ID, because only the variant associated with the order line has information about the current stock count. Back in the job template, we'll assign the result of the order lines query to an order lines variable and iterate through each order line so we can add the variant ID of the order line to a list of variant IDs. We'll pass that list to yet another query that I call variants. We'll pass it the company ID and the list of variant IDs. Let's take a closer look at the specifics of the query. Its name is variance. It finds documents of the class variance, but only those that belongs to the specified company ID and has an ID that matches any of the variant IDs that was referenced by an order line. We're only interested in a single information about each variant, and that's the stock count. So to recap, the job now knows which open orders exists for the specified company and which order lines each order is associated with. It also knows which variant each order line is associated with. Therefore, the job should be able to determine which orders are in stock and which are not. Most of the remaining lines are calculations that iterates through each order and determines if all of its order lines are associated with variants that has a sufficiently high stock count. For each order, the verdict is then assigned to a variable called printable. And printable can either be true, we can print the order, or false, we can not. I want to be absolutely sure that the app never attempts to print an order twice. So I'm going to introduce an order attribute that I call print state. The job should first check if the order already has a print state. And if it doesn't, it should be given one. We can do that with the liquid filter called dbupdate1. It's just another query to the Goecommerce database. Except this time, we're not asking for informations. Instead, we'd like to update the order in question with the print state printing. We'll pass it the company ID and the ID of the printable order. So this query is a little bit different from the previous ones. It's called update order, and it queries for an order that matches the specified order ID and company ID. The new and different part here is the document attribute and its set operator. If an order is found, this operator will update it with a print state attribute that has the value we passed, which for now is printing. Before the job can actually print anything, we need to decrypt the address attributes of the order. Since these attributes are sensitive, GoFetch encrypts them before saving them in the database of the app. But we can decrypt them with the liquid filter called Decrypt. But how do we actually print the order? Printing the address on a piece of paper isn't very useful. Rather, the merchant handling this order needs a shipping label from a carrier like UPS. To print such a label, Goecommerce is going to use an external service called Shipmondo. If the merchant has a Shipmondo account, Goecommerce can use the liquid filter Webhook to purchase a shipping label through Shipmondo's API. We'll call the Webhook print order and pass it a load of informations, including the now decrypted shipping address of the order. But we also need to pass it a sender address. And as you can see, we pull this address from the company document, in this case from Christopher's farm. And finally, we need to pass Shipmondo an authorization token specific to the company. Since these informations need to be saved in the company document, I've prepared a page called Shipmondo Index where the merchant can register them. It's just an HTML form with a bunch of input fields. This, for example, is the input field for the Shipmondo API token. The action attribute of the form will be translated into a patch request that looks like this. The ID parameter will be the ID of the signed-in user's account. The request will go to the template called Companies Update, but instead of spending time reviewing it, let's instead clean things up and visit the Goecommerce website to fill out the form at the Shipmondo Index page. Off screen, I found the authorization token of my Shipmondo account, and I will fill the rest of the form with the details of Christopher's farm. The print order webhook that can now be passed both sender address, receiver address, and a Shipmondo API token can be found under Webhooks, Jobs, in a file named print orders, same name as the template file it belongs to. The webhook is a post request to a specific Shipmondo API address that, as the name implies, creates shipments. And the headers will include an authorization key with the Shipmondo API token. Two addresses will be included in the request body: the address of the sender, which I just registered, and the address of the receiver, which was decrypted from the order. The print attribute, if true, signals the intention to print the shipping label on whatever printer the merchant has registered in their Shipmondo account. Shipmondo enables a little piece of software to be installed in your own network so they can communicate with your printer and print the label. Finally, we're gonna include a reference on the shipping label with the order number and a packing list. Back in the job template, if the API request is not successful, it will not return a 200 OK response. In that case, we'll use the DB update 1 filter to update the order with the print state failed. But if successful, we'll update the order with the print state printed. While I've been talking, Christopher's farm has received a new order, so let's check it out in Shopify. The ordered quantity is 8, but by visiting the product, we can see that we are too short of being able to ship the order. Since GoFetch transfers all data to Goecommerce, we can find the same order here. The order line links to its associated product, and since even products without variations has their stock count stored in a separate variant document, we can follow this link and review the stock movements. The situation is as follows. We had 6, 8 was ordered, which brings us to -2.
But every day I get new deliveries. Today I can increase the stock count by 8. It seems that GoFetch successfully requested Christopher's farm to change the stock.
If we tap back to the Shopify merchant account of Christopher's farm and reload the product page, we can see the available quantity has gone up from -2 to 6. Since GoFetch has immediately transferred this change to Goecommerce, we can see the new stock count here too. And since a webhook from GoFetch notified Goecommerce about the event and activated the print orders job, Shipmondo was requested to print a shipping label on the printer registered by Christopher's farm. By inspecting the details, we'll see the correct sender address, the correct receiver address, and we even see the reference containing the order number and the packing list. But what about the state of the order in the shop? Let's check out the rest of the print orders job in the Goecommerce demo repository. The job makes one more request to the GoFetch shop API with a webhook named Create Shipment. The specifics of the webhook looks like this. As the previous one that changed the stock count of a variant, it's a patch request, and as the URL indicates, it creates a shipment for the order with the specified order ID. Let's visit the Shopify merchant account of Christopher's farm one last time and find the order. The status of fulfilled confirms that a shipment has in fact been created. The changed state of the order will quickly find its way back to Goecommerce through GoFetch. As we can see, that has already happened. And that concludes episode 3. A merchant using Goecommerce still has to physically pick and pack their orders, but everything else is now handled with QR codes and automated processes. So as promised, an app that could be useful to any e-commerce company growing their own products.
In any case, I hope I have demonstrated the potential of Goaddon and inspired you to build your own apps using the same techniques. However, if you're only inspired and not prepared to do the work yourself, you should watch my next episode where I demonstrate how we can build your app.